Oh, welcome and thank you for joining. Let's take a look at some examples of adding and subtracting rational expressions. This time we're considering rational expressions that have different binomial factors. So step number one would be to inspect what you have. You have two terms in this rational expression. And next we are going to factor the denominators. So we have x. We have a common factor of 6, x plus 1, and then plus 5. A common factor of 4, and then x minus 3. So next we have to find the lowest common denominator, and for this we will have to list the factors. I'm going to start off with the binomials because they're easier actually to spot and kind of identify and put them into a lowest common denominator. So I have x plus 1 and x minus 3. So since they are different, so I'm going to give them a different spot. So I'm not going to list them below each other. And then I have the numbers 6 and 4 that are factors in the respective denominators. And I know that number 6 can be 2 times 3. And number 4 can be 2 times. Now, I don't have any factor of 2, so I can write 2 in here, for example. And I know that this is probably a very elaborate way of explaining how to find the lowest common denominator. But obviously, you can take a shortcut because you can tell and you can see that the lowest common denominator of 6 and 4 is going to be equal to 12. Right, so, but I'm explaining this as if, you were probably in the younger, more junior grades, and you are still working with the lowest common denominator of numerical values. So we're going to state the lowest common denominator here. So we're going to bring 2 down, which is a common factor. We're going to bring number 3 down, which is a factor in the first one. We're going to bring x plus 1 down. This is going to be a factor in the lowest common denominator. Next, we have x minus 3. So that's coming down as well. And then number 2, which is a factor. And we're going to say that in a simplified form. I'm going to have to bring the 2, the 3, and the 2 in here together. That will give the 12th as a common factor, x minus 1, x minus 3. So this will be the lowest common denominator of our expression. So what that means is that now we're going to work with this expression to make all the denominators the same as 12 x minus 1, x minus 3. So as you can see here, the first denominator has a 6 and an x plus 1. So a 6 has to become a 12. How do we do that? We multiply by 2. And we have to multiply by 2 the numerator as well. And it also needs a factor of x minus 3. So we'll multiply by x minus 3. So since we have the luxury of doing this, let's make this look nicer. And we have x plus 3 to the numerator as well. Now, in a similar way, we deal with the next rational expression. We have 4 that is getting ready to become a 12, so we'll multiply this by 3. Don't forget to do the same thing to the numerator. And we have x minus 3. We're missing x minus 1, which means that we're multiplying by x minus 1 here, both numerator and denominator. Now, we are going to simplify this expression. We see that the denominators are the same, which means that we're going to draw one long line here to host our very large denominator, 12 x minus 1, x minus 3. And then in the numerator, we'll have 2 and x multiplying x plus 3. And then 3 and 5, which is 15, multiplying x minus 1. So continue simplifying a little bit more. The numerator would be 2x squared plus 3x, and then plus 15x minus 15. And this will be over 12, x minus 1, x minus 3. Never, ever expand the denominator. That would be cruel, actually, because then it's going to take a long time to see if you can simplify it, let alone that is work that goes to waste. So we have 2x squared. We have 18x. and then we have minus 15. And down in the denominator, we have our denominator in factored form. Oops, sorry here. Which is 12, x minus 1, and then x minus 3. So one last step that we want to take is check and see if the numerator is factorable. In other words, we're trying to find if there are two numbers that multiply to negative 30 and add to 18, and that's not possible. If you want to find a quick answer, you can check and see if there are zeros to this expression, and there aren't. So this would be the most simplified form of it. Now, if you look at the entire process of simplifying, you probably notice that we missed something in here, and that would be the restrictions. And whenever we are adding and subtracting rational expressions, it is okay to state the restrictions at the end, providing that we know exactly where to look for the restrictions. Now, in our case, we haven't simplified any x's from the denominator or any expression that contains x in the denominator, which means that we can easily get our restrictions from the lowest common denominator. And we're going to say that the restrictions are that x minus 1 has to be different than 0. So that means x different than 1. And x minus 3 different than 0, which means x has to be different than 3. So in the next example, I encourage you to try this on your own. We have 2x minus 1, 3x minus 3, minus x plus 1 over 4x plus 8. So let's get to work. 2x minus 1, factor the denominator, 3 times x minus 1, minus x plus 1, factor the denominator into 4x plus 2. So the lowest common denominator, we can do this a little faster, and I'm going to show the faster way and a more practical way of finding the lowest common denominator. You look at the numerical factors, 3 and 4. The lowest common multiple of 3 and 4 is a 12. And then you check and see if the binomial factors are different. They're both part of the lowest common denominator. We are right here at the lowest common denominator, so why not state the restrictions? So everything becomes a lot faster, a lot easier, as long as we know the process and understand the process, right? So an x plus 2 is different than 0, when x different than negative 2. Now we're going to make the denominators the same. So the denominator has to be 12x minus 1, x plus 2. And I can use this very expression that I have up here. So we'll make number 3 into a 12, so multiply by 4, both numerator and denominator. And we need to bring in the factor of x plus 2, so multiply by x plus 2, both numerator and denominator. So in the same way, we're going to treat this rational term. Number 4 has to become a 12, so multiply by a 3, both numerator and denominator. This is a binomial. Keep it in brackets. And we have a factor of x plus 2. We need x minus 1 to come in. So we are going to multiply by x minus 1, both numerator and denominator. So now that the denominators are the same, 12 x minus 1, x plus 2, 12 x plus 2, x minus 1, we're going to write the entire expression into a single rational expression. So we're going to have in here a 4, 2x minus 1 times x plus 2, minus 3, x plus 1, x minus 1, over the lowest common denominator, 12x minus 1, x plus 2. So in the next step, we're going to work on our numerator here. Now remember that in this numerator you have the product of 3 things here minus the product of 3 things here. So here you're multiplying monomial, binomial, binomial. So when we have a monomial multiplied by 2 binomials, I first expand the 2 binomials, because if I multiplied by the monomial first, these coefficients will get larger, and then I have to multiply the larger coefficients with something bigger than a monomial. So I think it's more practical. There is no rule, because The order of operation obviously is the same, so you can start anyway, in any way, so you can multiply by 4 first. But I encourage you to do the binomials first because it makes it a little bit easier. So 2x squared, so 2x squared plus 2x minus 1x is 4x minus x, and then minus 2. You can do this in your head, obviously, so that's 3x, but I'm writing all the steps in here. And 3, you probably recognize the difference of squares formula here, a plus b minus a minus b, so that's x squared minus 1, and that's over 12, x minus 1, x plus 2. And that would be equal to, so we have to keep on simplifying. So 4 multiplied by 2x squared, 8x squared. Now 4x and negative x will make a positive 3x. So to make my steps a little bit shorter, so I will multiply 4 by 3x, a 12x, and then minus 8, and minus 3x squared, and then plus 1. See where we get that from, right? And denominator, nothing changes there. Please do not expand the denominator. And lastly, we have 8 minus 3, that's a 5x squared. And then we have 12x, and then we have minus 7. And in the denominator, we have our amazing denominator here in factor form. And we're going to check and see if it is possible to factor out the numerator. And as you can see here, two numbers that multiply to negative 35 and add to a positive 12. I don't think that exists. I did try, but it doesn't, which means this is not factorable, which means they're not factors that we can simplify. Numerator with denominators are possible factors. This would be the final answer. So in the next example that I want you to try, obviously, on your own again, we have a little bit of a more unique example. So we have 5 over x, 2x plus 1 over x plus 4, and minus 5x over 2x plus 1. So let's get to work. So I'm going to start off with the lowest common denominator, which means that I need to factor all the denominators. And I see that I don't really have any factors in either denominator. So I'm going to get started with finding the lowest common denominator. As you can see, all the denominators here are pretty unique, right? And all the denominators are factors of themselves, right? So the lowest common denominator would be x, so the product of all three of them, x plus 4, and then 2x minus 1. And since we're at it, we're going to state the restrictions, which are, number 1, x cannot equal 0. Number 2, x plus 4 cannot equal 0, which means x has to be different than negative 4 as well. And 2x minus 1 different than 0, which means that 2x has to be different than 1 and x different than 1/2. So in this case, we got 1, 2, 3 restrictions for x. Now we're going to get to work and make all the denominators equal to the lowest common. So 5 over x is going to need a factor of x plus 4 and 2x minus 1. So same thing with the numerator. Now, the next term, which is 2x plus 1 over x plus 4, is going to need a factor of x and a factor of 2x minus 1. So we're going to give the numerator same factors. And we'll remember to put brackets around the binomial numerator. That's important. And lastly, we have negative 5x divided by 2x minus 1. So here we're going to need the factors of x and x plus 4. So numerator gets the same factors too, understandably, right? And now next we are going to bring all these terms under the same denominator. So let's do this. So it's going to turn out to be an interesting expression. Never ever expand the denominator. I can't emphasize this enough. And it's kind of funny, but it feels repetitive, but it happens all the time. So sometimes we get too desperate and expand this, which makes no sense. Now, we're going to do what we were saying before, expand the binomials first. So careful, it's very easy. There are lots of calculations in here and simplifications, very easy and lots of opportunities for mistakes. So always do the steps and double check. So 2x squared minus x. And then 8x minus 4. Whew, done with this. And then we have plus. So I'm going to leave the x down here, and then I will multiply 2x plus 1 with 2x minus 1. Very happy to see the difference of squares here. So that's 4x squared minus 1. And then minus, we have 5x and x will make 5x to the power of 2 times x plus 4. So here we are. I'm going to make this a little bit smaller so that we can have enough room in here to continue our simplification. Sorry about this. So this will take a second. And we'll continue our simplification down here. So we are going to expand 5 by all the terms in here. Remember, negative x plus 8x, that's a 7x. Just to save a little bit of time, I'm going to show that in there. So we have 10x to the power of 2. And then 5 and 7x, 35x. So 5 and 7x. And then 5 and negative 4, negative 20. Let's draw this big fraction here. And the denominator as well, because why not? And now we're going to do the next group of terms. So x times 4x squared minus 1 will give positive 4x to the power of 3 minus x. So 4x3 minus x. And then we have negative 5x3. And then negative 20x. And here we go. We have the entire expression together. We'll simplify the numerator a little bit more. So I'm going to do the denominator down here first. Tedious and annoying to keep on writing the same thing that doesn't change, but that's the way it is. That's what we are supposed to do. 4x cubed and negative 5x cubed, they seem to have or to be like terms. They seem to like each other. Negative x cubed for these two terms. Now we're going to look at the x squared terms. So for x squared terms, we have 10x squared. Do we have any other? No. So we're going to have plus 10x squared. We're going to move on to the x terms. So let's see. The x terms, I have a 35 in here, and we have a negative 20 and a negative 1. I almost missed that. So negative 20 plus 35, 15, minus 1, 14. X. And lastly, we have the constant term, which is minus 20. And that would be the simplified form of the numerator. And normally we would have to check and see if this is factorable. And the only way that you know how to factor in grade 11 is factoring by grouping. We learn how to factor a degree higher than 2 polynomials in grade 12. So we're going to leave the answer in this form. And remember that the restrictions are that x cannot equal 0, negative 4, and 1 over 2. Thank you for learning with me. Bye for now. We'll continue with the next examples in the next video.